I have one slide I wanted to show, but I'll wait just a minute before I put that on. Can you hear me? Okay. You know, when they're prepping people on how to be an effective speaker, they always say you should start off with a story, something to get the people wake up. But I don't remember stories, or I don't remember the punchline, or if I remember the punchline, I don't remember the story. But one thing I did find out when I've traveled around a bit, and wherever you are, the people make jokes about their neighbors. See, when I grew up in Kansas, they always made the jokes about the hillbillies in Arkansas, the next state down. When I was in southern Germany, they made jokes about the Bavarians, who were just a little farther south. When I was in northern Germany, they would make jokes about the Freelanders who lived there. And when I was in England, they all made jokes about the Irish. And so I was in the pub one night after work, and a crowd of people there, and this little Brit comes in. He says, "Say fellas, have you heard this latest joke about the Irish?" And this big hulking guy gets up, looks like he just came off shift at the mines. He walks over and he looks down, and he says, "Before you start telling a joke about the Irish, I want you to know I'm Irish." The little Brit looks up at him. He says, "Gee, I'm sure glad you told me that. I'll be careful to speak real slow and I'll explain all the big words." But where I live now, on the outskirts of Seattle, there are a lot of Scandinavians there. Any Scandinavians here? Hey. You know, one thing, the Scandinavians, they never tell jokes about anybody. I don't know what there is about them, but they do like to reminisce about things that have happened to them. And so, one of the first things they told me when I moved there was about these two fellas that lived there, and it was Sven and Lars, and they'd been boyhood friends. And they started courting the girls at about the same age, and they both got engaged about the same time, and about the same time they decided to get married. And so they went down to the courthouse to get the marriage license. And Sven was going to marry Helga, and Lars was going to marry Olga. So they went up to the clerk, and they gave him their names. So he wrote out the license, gave them a license. He said, "That's $5 each." And so Sven and Lars each gave him $5, and they took the license, and they started to go out the building. And then they took a close look at the license, and the clerk had mixed up the names. He had Sven marrying Olga instead of Helga, and Lars was marrying Helga instead of Olga. So they went back up to the clerk, and they said, "You know, these licenses aren't right. You know, can we get a new license?" He said, "Oh, sure." He said, "I can change the names around, but that'll cost you another $5 a piece." And so Sven said, "Lars, come over here." So they got over, and where the girls couldn't hear him, he says, "Buddy," he says, "tell me truly, do you think there's really $5 difference between these girls?" Can you read this? Anyway, this is a memo dated the 10th of August, 1945, from General Leslie R. Groves to the Chief of Staff, whoever the Chief of Staff was. And the key word here is, said it had been, the next implosion type weapon had been scheduled to be ready for delivery on the target. Now, 2 have already been delivered. This is the 3rd weapon. And he says, we have gained 4 days on the schedule. So now it'll be ready to be shipped on or about the 12th or 13th and be ready for delivery anytime after the 17th of August. At the bottom is penciled a note. It says, It is not to be released over Japan without express authority of the President. And I can't make out the signature. I don't know who signed it. All right. The last few days, over the TV, radio station, there have been a lot of talk about whether we were prepared to continue bombing Japan or not. Anyway, how did I get mixed up in this potential third bomb drop? It turned out that one of the things we wanted to measure was the response of the airplane when the blast wave hit it. Now on the first shot at Trinity, there were supposed to be two B-29s orbiting over the tower to be roughly in the position where they would be on the actual drop. And these two B-29s flying out of Holloman Air Force Base. Well, as you know, there was a thunderstorm and the shot was delayed and the weather was bad and the planes never did get into position. So on the first shot, planes were not where we hoped they would be, and so no information was gained. About that time, decided they wanted to get some kind of on-board aircraft measurement of the lurch of the airplane and the response. And so, for unknown reasons, I got tagged to gin up a little experiment to measure that. So I'd made some transparent tubes out of lucite. They were about so long, series of them. And inside each tube had a weight and various strengths of springs. The idea was that using Hooke's law and that when the plane jumped up, when the shock wave hit it, because of the different spring constants and weights, we'd be able to see the motion of the plane, since these weights would act fortunately as inertia measuring devices. And this was all calibrated with lines, and I had a camera sitting across the bulkhead to record this. Well, about the 10th of August, got a message back which said no measurements. Now that's real helpful in trying to troubleshoot something. And so what do when all you know is no measurements? Don't know if the camera didn't work, don't know if it was a bad idea, don't know if they forgot to turn the camera on or anything, just no measurement. So anyway, my boss at the time, Julian Mack, decided that since I was responsible for generating this Rube Goldberg, that they would send me over on the next drop and run the camera and make sure that they got measurements of the lurch. There were three airplanes. There was a drop airplane, there was the airplane that dropped the blast canisters, which were on parachutes, and then the third airplane, which was for photography and for instrumentation of the plane itself. This would have been on the third airplane. How many of you went overseas in World War II? How many of you took all of the overseas shots? How would you like to take the whole series in one day and not tell anyone and go on to work? Anyway, we were scheduled to leave Los Alamos on Wednesday. We would have taken there was enough material on hand at that time to fabricate 5 of the Fat Man implosion type weapons. They were not yet fabricated, but there was enough material, enough plutonium to do that. And so what General Groves is talking about here is that the next core would be fabricated, ready to go. So there's going to be a crew leaving Los Alamos, go to Albuquerque, fly to Hamilton, San Francisco, fly to Hawaii, fly on to Quads, fly to on out to Tinian, and I would have been with that crew. All set to leave Wednesday. The Japanese surrendered on Tuesday, one day before that. And so by one day, I missed being a footnote to history of being involved in the third drop, if there had have been a third drop. Now, the device was finally put together and was detonated as the first shot on the Crossroads series next February, when the Crossroads series went. So that was the third of the plutonium devices that were possible. The fourth one then became the second shot, which was the underwater shot of Crossroads, where you see the pictures of this huge plume of water. The fifth one was going to be a deep underwater shot in the deep water. However, that was canceled, was never carried out, and so the core of the fifth weapon that had been ready in the material was ready in the summer of 1945. The core was taken out and was made into the Jezebel bare critical reactor, which worked at Los Alamos up until the mid-1950s. I would like people to ask questions or anything as we go along. Next thing I wanted to talk about was the shot Cherokee, which...
Excuse me, Ed?
Yeah.
I have a question.
Sure.
How come it took an eternity for this letter to be declassified?
When Congress... All right, the question is, why did it take so long for this letter to be declassified? When Congress set up the Atomic Energy Commission, everything related to weapons fell into a special classification category. Then in 1954, the Atomic Energy Act was rewritten and a new set of classifications were drawn up. And at that time, the military got into the act, and we set up our current confidential, secret, and top secret series of classifications, but there are subcategories within that. And top secret is downgraded on a 12-year interval, secret on a 6-year, confidential on a 7-year interval, and so on. There is a critical nuclear classification, CNWDI, critical nuclear warhead design information. Anything which is classified as CNWDI, as we call it, CNWDI, is never declassified, never. Everything related to weapons became classified as CNWDI in the files. And so there is never any automatic declassification on anything related to weapons. It's only when there is some inquiry or some reason to resurrect the material and some new officer or some person with the authority to declassify takes action and does it. This came about by someone digging in through the Freedom of Information Act, and one of my nephews came across it and sent me a copy of it. I didn't ask for it myself, I just came across it accidentally. That's since critical nuclear information, there's no automatic downgrading of it as there is on most things. Is why so much of the material is still classified. And in my own opinion, that's one of the reasons we have so much anti-nuclear feeling now, is because all of the people who had knowledge, who knew what was going on, who had worked with the field, were never allowed to talk about what they were doing or what they knew. And so whenever anything happens, you always have people who are against it. And so we've had the people who started out being against nuclear had a complete free field. No one with knowledge was ever allowed to say what they knew to rebut it. And so we've had a free field for anti-nuclear propaganda for 50 years. And so we have this very large body now of anything nuclear is bad, no matter what it is. Okay. In going on to the Cherokee shot. Another question, yes?
I'd like to agree with part of what you're saying. There are lots of information available in the 50s and 60s about the operations of our weapons program. For example, the first international conference on the peaceful uses of atomic energy occupies 2 or 3 feet of bookshelf space, and it describes a lot of radioactive materials, fission product distribution curves, breeder ratios, and on and on and on. And I would like to describe the situation not simply one of secrecy, but one of laziness on the part of journalists and others who have had a field day misrepresenting the technology. It's there in the library. Any good science library has huge volumes of this stuff. And each paper in those volumes has 30 to 60 technical references going back, even preceding the Manhattan Project when it comes to natural radioactivity.
May I rebut that just a bit? Even though material appeared in the literature, those people with top secret clearances were not allowed to confirm. And I think I agree with Ed. Even though it was published, and we had a lot of the more modern weapon information from the Soviets was published, the people actually working in it were not allowed to confirm or deny it. It was part of your clearance restrictions. So the people who were knowledgeable could not officially comment on it.
Yes, both parts, I think, of the questions and answers are correct. There has been information available in the libraries, but the vast majority of the voting public don't go into the libraries to dig up that kind of information. They depend upon what's in the morning newspaper and what's on the latest TV news. And it's very true that people working in the field who had direct knowledge were never allowed to say directly what they knew. There was a time when anything that I wrote was classified confidential, no matter what it was, just because I was the one that wrote it. And that happened to me because I was involved in some curious programs. And things like that, you know, have contributed. So it's both sides of the question. I think the secrecy overall has been more hurtful than helpful to us. Well, that's one person's opinion. Okay, shot Cherokee. This was scheduled to be the first day of May, 1956, over Bikini Atoll. This was to be the first thermonuclear weapon dropped from a B-52. If you've ever been on one of these field tests, it is a frantic, physically exhausting activity. There's never enough money, there's never enough time. From the technical side, you're desperate to try to get some information that you need from the weapon effects. And so you try to make up with physical labor and putting things together on the site for the lack of advanced planning and checkout and money and crew and all the rest of it. So I was over on Eniwetok Atoll, and it was a joint Air Force Army program to principally to measure any potential fallout from this device. It was supposed to be an air blast to be detonated about 4,000 feet. The predicted yield was about 3.5 megatons. Both of these turned out to be correct. The actual burst height was about 4,300 feet, near as we can tell. The actual yield was just about 3.5 megatons. But we had a whole bunch of stations, recording stations, to measure ionizing radiation, fallout, and so on, scattered all over the atoll. And one of the places we put them is on the reef. Now, the atolls, you know, are a circle of islands, and you have inside the circle, you have a lagoon, and then on the outside edge, on the ocean side of each of these islands, you have a reef, which has been built by the coral. And this reef extends anywhere from 100 feet to 300 or 400 yards from the islands out until you get a drop off. At low tide, there's just enough water on the reef to keep the coral wet. And the coral keeps growing to keep up with the sea level if the sea level rises. Okay, at high tide, the water can be 4 feet deep or so on, and the waves come washing in. Well, the last 24 hours before a shot go off is especially frantic, because a lot of our stations had electronic equipment in them, and we had batteries that would run for 24 hours, and so we had to go around this whole string of stations, put in new batteries and everything. And so the 24 hours before, especially frantic, and then you go to your evacuation stations and wait for the shot to go off, which is usually scheduled the next morning. Okay, so the 1st of May, we're all set, all dead tired, go through the whole routine, and next morning the shot is canceled. The weather is not exactly right. We were, at that time, we're very, very cautious about the weather patterns, because if you remember, just 2 years before this, on the Castle series, the first shot, Castle Bravo, the fallout pattern drifted from where it had been predicted a little bit, cut across the island of Rongelap. Some natives there were exposed. There was a Japanese fishing boat, the Lucky Dragon, that got heavy exposure, and so there was a lot of concern. And why did they miss on predicting where the fallout pattern would go? Well, first place, the yield was a lot bigger than anyone had expected. In the second place, the winds did shift a little bit. Third place, the cloud went lots higher than anyone had expected. Well, how could anyone miss the cloud that much when we had the Ivy Mike shot, 11 megatons, not much smaller, on a series preceding that? The Ivy Mike had been the first large-scale thermonuclear weapon. The reason we missed the fallout pattern on the Ivy Mike shot was because we didn't make any measurements. And the reason we didn't make any measurements was curious. There had been an elaborate plan to have platforms to measure the fallout. And in the lagoon itself for the island, there were rafts put out to catch the fallout so we could measure the fallout. And out in the ocean, hundreds of miles away, they'd come up with a tricky way of mooring small boats, 15-foot boats, in 12,000 foot of ocean and keeping them in position. They did that by putting a heavy weight, several tons, down on the ocean floor. Turns out that there's a company that manufactures piano wire that can make saltwater resistant bronze wire in one continuous strand as long as you want it, 2-3 miles long. And so by getting the saltwater resistant bronze wires tied to this heavy weight on the bottom up to a float now, which is anchored just at the thermocline below the wave action, which at that time was about 200 feet below the wave surface. And so now you have a float pulling up on this line, the big weight holding it down, and that gives you a place to anchor a small boat. Little boats were anchored now just 200 feet down, scattered out the Miami Mike fallout pattern might have been. And then the politicians got nervous about foreign traffic of where the fallout might go. And so they decided that these small boats were too much interference with their radar sweeps, and so they were all taken out. And so there were no fallout pattern. And so that was one of the, so immediately after the Ivy Mike shot, boats zigzagged back and forth through where we thought the fallout was going to go to measure the radiation in the water. Well, it turned out particles were bigger than anyone had expected, so they sank faster, and the amount of that was dissolved in the surface seawater was a factor of 7 less than what we had expected. And so we did not get good fallout measurements on the Ivy Mike shot. We did get good measurements on the platforms that were in the lagoon. In fact, there was so much fallout that we could actually weigh the fallout. And years later, that turned out to be very valuable when we were looking at certain aspects of the crater formation and so on. But anyway, the Bravo shot had complicated the problem, and so they postponed the shot on Cherokee. So we go through the whole rigmarole again to get ready for the next shot date. And this is another frantic 20 hours of work getting ready for that. It's postponed again. We do it the third time. It's postponed again. The weather won't cooperate. We did this 20 days in a row. And everyone, at the end of 20 days, you're on the ragged edge of exhaustion. Your tempers are gone. That's one. But anyway, we did this for 20 days. And not only that, by that time, the tides in the daylight are gotten out of sync. And so when it comes the scheduled time to replace the batteries in all my reef stations out on the reefs is now high tide instead of low tide. And so I've got to go out 100 yards or so in water which is now chest high and the waves washing over me to put in new batteries. And then I wade back to shore and the helicopter takes me to the next island. And so here I am, to keep my feet on the ground, I put the batteries overhead, and so I go trudging out, and I notice these fins, not very big, and they go around this way, and they're just checking out, to see if lunch is ready or not. But the next island, it gets a little tougher to walk out, and but anyway, they never came any closer than just a few feet, but there were times when there would be as many as a dozen of these fins going round and round. Well, actually, finally, we did on the final day, we did it all again. By this time, there's a storm somewhere off in the Pacific, and the rollers are coming in, big rollers. And so my group is late getting our stations all armed, ready for the potential shot the next day. And so the ships that where my station was on board a ship, normally I go out on a boat in the lagoon where the water is calm, get on board the ship. The ship was already left the lagoon and gone out to their station out in the ocean. And so the Navy get one of their little boats, and they take me out the lagoon, out to the ocean, so I can get on my ship. Well, these rollers are coming in, and this cruiser is bouncing up and down in the waves, The little boat I'm on is going up and down like this. And I look at the plimsoll line on the ship, and it's going up and down 40 feet between my boat and this cruiser. And so the Navy crewman pulls right in, doesn't bother him in the least, pulls his little boat right in. They throw a Jacob's ladder down, and he says, when I yell, you jump. And so, so anyway, I jump when we're up at the top of the swing. I get on the Jacob's ladder and go up. He takes his little boat, goes off. I don't know where he goes to. He was unconcerned the least. So he went somewhere else with his little boat. But anyway, next morning, time for the shot. It's daylight. So I'm the only Air Force officer. By this time, I'm a captain in the Air Force. Only Air Force officer on board this Navy ship. And so I'm going to show them how the Air Force does things now. And we're going to have a B-52 drop this Cherokee bomb. So in the morning, I put on my dress uniform, I put on my pilot wings, I go up and standing where they can see me and wait for the shot to go off. And the B-52's up orbiting around in the bomb pattern. And over and over again, we do this, downwind leg, turning. And the pilot to bombardier conversation is radioed down and on the loudspeaker on the ship. And so -5 minutes, T minus 2 minutes, T minus 45 seconds, T minus 30 seconds, T minus 15, 10, 5, and then we'd repeat it again, going through. So finally we came up on the bomb drop. So he said, T minus 5 minutes, T minus 2 minutes, T minus 1 minute, T minus 45 seconds, -5, 4, 3, 2, 1, bombs away. Uh-oh, something's wrong. Bombardier, on the final bomb drop, had left 30 seconds out of his drop. And so B-52 goes roughly 500 to 600 feet a second at those altitudes. 30 seconds off, 3 miles off of the target. All of the experiments were set up to measure the blast wave coming from here. The blast wave came from here, hit everything side on, all of the blast measurements flattened. The Navy crew, I said 20 days of my ship, I very quietly tiptoe down to the stairway, go down to my bunk, take off my uniform, put on fatigues, come back up. I was not going to be the Air Force representative on a ship that had gone through 20 days and what they had gone through, when that happened. Well, it turned out that it couldn't have been any better for my particular experiment, because where all of our reef stations were, that we thought we're so far away from the blast where we might get some fallout if there had been fallout, we're now close enough to where the blast actually was that we got good prompt radiation measurements. First time we'd ever gotten good close in, unperturbed, no fallout. The water kept everything clean from that kind of weapon. I couldn't have been happier about it. But I still kept my fatigues on until I was clear of the Navy. The next one I'd like to tell you about was the next year, and this one took place in Nevada at the Nevada test site, and this was Shot John. This was the first air-to-air nuclear warhead air defense weapon. In those days we were expecting potential bomber raids, and so one of the schemes to defeat bombers was to put a nuclear warhead on a air-to-air rocket, and so the fighter aircraft would come up, intercept the bombers, fire this nuclear warhead, and blast the bombers. The first one was unguided. The rocket, when it was fired, this was the MB-1 Genie rocket. The rocket fired straight ahead, no maneuvering, and so all the guidance was done by the pilot before he released the rocket. And so then my task, since in those days I was responsible for the radiation measurements in the Air Force, was safety of the crew. And so the scheme was the flying straight ahead. These were F-89 aircraft, were the first ones that were to be implemented to carry this weapon in the air defense role. And so you fire straight ahead. If you keep on flying straight ahead, when the weapon goes off, creates a fireball, you're going to fly right straight in the fireball, which is not good. So you have to turn away from it, and so everything has to be carefully coordinated. You want to be as close as you can to get as much accuracy before you fire, but you want to be able to turn fast enough so that you're sure to escape. And we never yet, this is up in 1957, there have been a lot of detonations, we have never yet, up until that time, had a completely clean measurement of the radiation from a weapon when the weapon is in the air and the receiver is in the air. All of our receivers had been on the ground up until that time, or there'd been ground shots where we had airplanes up above. We'd never had the single combination of a free air burst and a stationary recording station where we could measure the radiation. And we didn't really know in those days how much perturbation the ground interface was doing to our measurements. We knew there was some perturbation, but we didn't know how much. And so I've got two problems. One of them is here's an opportunity to get measurements in the free air from the weapon detonation and from a recorder. And my other problem is, what am I going to tell this crew how to turn? That's my responsibility. So we did the best we knew at the time, and I had to pick a radiation safety dose too. What's safe? So I picked a number out of the air, which seemed reasonable, and it's still the criteria. And yeah, you got to be careful picking numbers out of the air. You know, sometimes they're reasonable, and this one has turned out to be reasonable enough. It's still the Air Force criteria. So then I decided, well, I got to get permission to expose these crews to radiation. You know, I'm not sure what it is. And so who gives this kind of permission? I mean, I couldn't find the table of organization, anybody who has the authority. So anyway, I wrote a letter off to the Air Force Surgeon General. I thought this is a medical problem. And so I had a little paragraph describing what we're going to do. And there are going to be 3 F-89 crews. And I say the radiation is uncertain, and under the worst circumstances it would be lethal to the crew if everything goes wrong. And so a couple of weeks, very quick actually, I got back a letter from the Air Force Surgeon General, and I would dearly love to have a copy of that, but it's one of these things that's secret and I haven't been able to retrieve. And it says, to Captain Ed York, you are hereby granted permission to kill 3 F-89 crews. Well, I took this letter up to the Air Defense headquarters in Colorado Springs. Man, that was the best thing that could have happened. Crews couldn't have thought of anything better. There was instant competition to be one of those 3 crews, you know. Man, the Air Defense Command loved it. They got pilots motivated like they've never been motivated before. They wanted to be one of those crew people. And so they held a big competition all over the Air Defense Command, and they picked absolutely the 3 best F-89 crews. Each one is a 2-man crew to practice up for this. And I had a lot of liaison with the crews and all the rest of them, telling them what to expect, and I briefed them on blast wave and thermal and what the radiation was and how I wanted them to turn. And the aircraft were all instrumented with everything we could think of putting on the aircraft to measure the radiation dose. And so that was all set up. And second thing I had a chance to do here was if I could get a platform close enough to this burst, which was set to go off at 20,000 feet. In fact, we helped pick 20,000 feet because of this. Then I could have a stationary platform free of the ground and get this one measurement that I really wanted. So we got Aerocamp balloons. That's like blimps. So I had General Mills were making blimps in those days. Well, things turned out queer, don't they? Strange. Have to be careful of politically correct words here. Turns out that when you're making rolled oats, you get a lot of hulls left over. And one of the things these hulls are good for is to make materials which can eventually end up as a plastic, which is very good for making balloons out of. And so they were manufacturing a lot of the balloons that were used in the Skyhook high altitude program. And we got them to design some small blimp type balloons for us. And so we were using them tethered at 1,000 feet above the desert on a lot of the other shots. And so managed to get one up to 5,000 foot altitude, tied onto a tether line like a kite, and with instruments on it. And so that let me get close enough to the burst point. Burst was at 20,000 foot, mean sea level. The Nevada test site is a mile high. And so by getting a mile above that, I'm within 10,000 feet of where the burst point is, and I've got a steady platform. These fly nicely. And I've got all kinds of instruments up on that and on the tether line. Balloons are, aerodynamic balloons have to maintain their aerodynamic shape. if you lose the aerodynamic shape, the drag goes up too high, you turn into a big sail, and any wind at all blows you. Now, nice thing about the barrage balloons and aerodynamic balloons and this sort of thing is they can take an enormous amount of overpressure. All it does is crumple them in a little bit, compress them, and doesn't do any damage. Unfortunately, they can't take any negative pressure at all, because if the pressure goes negative, the gas inside expands, and to make these things get up that high at all, they have to be very thin. They don't have much reserve strength. And the peculiarity of blast waves is they're always accompanied by a negative pressure wave. So no matter what you try, you're always going to, where you're going to get any blast at all with a blimp, you're going to expose it to the negative pressure. It's going to rip the envelope. It's going to turn into a sail. And so you've got only a few minutes before you can rescue it. Pull it down, recover your instruments. Now, everything going into the forward area after one of these shots is very carefully choreographed. We all had cards where you're going to be every minute, where you're going to go, who's going to go, and for recovery. And since this was a very rapid recovery, I had to be back into my balloon anchor point, winch it down, recover the instruments, all within about 10 minutes after, because we knew that the envelope was on the balloon was going to rupture. It's going to turn into a sail. The first gust of wind that comes along is going to tear it all apart, scatter everything over the desert. We practice and practice and practice, you know. So okay, shot goes off. Perfect. Everything was perfect. 3 airplanes are up there, the delivery airplane, the instrumented planes on both sides. They fire, they turn off just like they're supposed to. Shot goes off. I and my angel car, we always had 2 vehicles. You never went to forward area 1 vehicle. We go roaring down. The guard post steps out with his machine gun. What are you doing here? I said, you know, I'm supposed to go through here at 5 minutes after burst point. No, you're not. The guard didn't have the right checklist. So I'm sitting there, standing there, foaming at the mouth about, here's my chance, one chance in years to get the measurement I want. There's a guard with his gun in my stomach, and I'm saying, I gotta go, you know. No, you don't. So I sit there and watch the balloon collapse. The wind comes along. It vanishes over the horizon. And so it's about 30 minutes before get things straightened out with the guard, and I go down to the forward area. Balloon is gone. Spent 2 days in helicopters, on foot, searching every place I could think of. Never found the balloon, never found a trace of it, never found the instruments, never found a single piece of data. And by then I had to get ready for the next shot and go on, since we have this series and you have about 10 or more events in a series, and you have to get ready for the next one. So I missed that one. But the pilots and the aircraft did superbly. By this time we had very good flight recorders. Back in 1945, flight recorders weren't very good. Matter of fact, magnetic tapes hadn't been invented yet, and so, but we had magnetic tapes now, and so all 3 of the F-89s had good flight recorders on them. We got good measurements, and then I noticed on all of them there was a negative blip just before the shock wave hit, and so I talked to the pilots. What's going on here, you know? And they said, oh, you know, you told us when the shock wave was going to hit, and we wanted to take the load off the wings just before it hit. And so they'd done precisely what they should do as a good pilot. If you know when you're going to get a sudden gust, they'd all pulled into a tight turn for the safe escape. And then when I told them so many seconds after the burst, the shock wave had hit, they'd all push forward on their sticks. Shock wave hit, and they pulled back again, but the measurements were fine. The dose measurements on the airplane were fine. Everything worked except my 1 balloon experiment. But we were able later on, by a combination of experiments and theoretical studies, to figure out this problem of how much the ground was perturbing the measurements that we wanted. And so that turned out eventually to be in good hands. So those are some of the war stories of things that I've managed to participate in over the years. So if there are questions. Yes?
Do you recall the doses of the pilots?
They actually received roughly 5 rads of prompt neutron dose, and roughly, I don't remember now, one of them got 3. They all got about the same neutron dose, but they got different gamma doses because they were, after the turn, they were different distances away when the latter part of the initial nuke, it was 4, 6, and 7 rads of the gamma dose, something like that. So the maximum dose they got was like 10 rads, which was well below the Air Force safety criteria for single exposure is 25 rads.
Where was the third bomb to be dropped?
I don't know. Of the target list, the 2 principal targets remaining were Kokura and Nagata, and I don't know which of those would have been. Sam?
I'd like to turn my back on you, and face the audience, if I may.
Surely.
I was at this hydrogen bomb service around Eniwetok that Ed has been describing, and I came shortly after the first one, which Ed described in horrendous detail, a disaster to put it mildly. So, as he's also described, they were taking no chances for the second shot. So it was very exciting for me. I was a youngster back in those days, just like Ed. Well, came the bang, and I watched it from an airplane, some miles off, and it was quite a fireworks show. And now we come on back to Eniwetok, and to settle on down. In my case, get ready to leave and go on back to the U.S. Well, these weathermen were no better then than they are now, and things changed a little over their predictions, and the winds reversed themselves, and I was taking a really very pleasant trip down along the sands of this atoll, looking out at all this gorgeous water and so on and so forth. And suddenly these little white specks began raining down on me. And I knew what it was, but I was too stupid to appreciate, the possible danger. Well, to make a long story short, a mutual friend of Ed and myself, I'm talking about Carl Houghton, who was the chief radiological officer there. He was an Air Force colonel. He was on the ragged edge of ordering the evacuation of the whole atoll and nearby atolls, but he didn't quite get to that point. So everything went on happily ever after. So not go correctly. And luckily my children don't have 3 heads.
Howard.
And was there a measurement of the exposure that you had from that fallout at that time?
Look, when I get up to talk in an hour or so, I'm going to focus on what I consider to be the utter stupidity of the United States government. I've just answered your question.
Another answer to your question. We were all very carefully monitored. I wore 3 different types of dosimeters all the time. We wore coveralls. We're taped into a coverall. We wore canvas booties, we wore gloves, we wore surgeon's hats when we went into a contaminated area. We had the radiation measurements with us. When we came out, we stripped off all of our clothing. The only thing when I was doing recovery on the atolls, I was soaking wet because I had to go out on the reefs to recover the stations, and so, you know, in addition to everything else, all my coveralls and booties and everything else were soaking wet, so I had to get a new set to go to the next one and so on. But we were very careful about monitoring the exposure of anyone who was in any way associated with the technical programs. Now, they seem to have not been so careful with a lot of the support people out there. And then years later,
I went over as an observer.
okay, I don't know how careful they were with you, but
The slightest.
because we were extremely we were always very careful. Then the records got lost. All of this careful record keeping, and so then a few years ago, when this became concerned, DNA was tasked with recreating the exposure. And of course, I was one of the people they interrogated. And I remember very well one of the telephone conversations, and this fellow from DNA calling me up and asked me, you know, what events I'd been on, and was I carrying a dosimeter on the events? And I said yes. And he said, would you mind telling me what's a dosimeter?